All right, this is lesson 4.1, our third and hopefully final video. And we have one last concept here. We talked about the amplitude of sine and cosine graphs in the first video, or second video. And now we're going to talk about the period. And the period for a trig function is the time that it's going to take it for a trig function to repeat. And you know already, a sine or cosine graph, it repeats every 2 pi radians. Well, what happens if you want to model, again, temperature, where the period is 365.25 days? Or if you want to model a heartbeat, where the period is every second. So what if you need to change the period? How do you do that in a trig function? And it turns out the answer is very simple, and I know I put the screen shade up here, but you've got the sheets in front of you, so you kind of know the surprise already. And the answer is, if you want to change the period, put a number on the inside and multiply it with the x. And that will affect the period. It's not the period, so if you say the period is 2, you're wrong. But it affects the period. And let's see how it affects the period. So we've got our graph here, and again, I know you've got your sheets in front of you, but just act surprised anyway. So let's graph here sine of x, and then here let's graph sine of 2x. And now we'll graph the second one, and the dark might make it hard to see. Let's see. There's sine of x, and here comes sine of 2x. And we get this graph, and let's just, oops, let's get rid of now that. We'll keep our graph here. We can see it nicer there too, but let's just look here. And now we get, instead of a single sine, this is 0 to 2 pi still, we get 2 cycles of our sine graph. It's still 0, the window's still 0 to 2 pi. I haven't changed that with the zoom trig. So what does the 2 do? It affects the period. The period used to be 2 pi, and now look, divide it by 2, the new period is pi. So it occurs twice as frequently. It cuts the period in half. So what do you think 5x is going to do? It's going to make that cosine graph appear 5 times as frequent. That used to take it 2 pi to repeat. Now divide it by 5. The new period, the new time to repeat for this cosine of 5x will be right there. It'll be 2 pi fifths. Or, in a window that goes from 0 to 2 pi, how many cosine graphs do you get? You get 1, you get 2, you get 3, you get 4, you get 5 cosine graphs between 0 and 2 pi. So it's going 5 times faster. And so that's our last concept for this section. We've got the amplitude, we've got the period. Now let's see, we'll sum that up and let's see if we can put this all together. So if you want to affect the period of a function, make it a sine or cosine function, make it occur more frequently, you put the number in here, we call that one b. So on the outside we call that a for amplitude, b is for period. The normal period for a trig function is 2 pi. So what do? You divide by whatever that coefficient is on the inside, and that will be your new period. Okay, let's put this together, and that will take care of our first section. So here's just some questions that show up on the homework where they don't want the graphs, they just want information. So look at this graph. Y equals 3 sine of x. Can you tell me the amplitude? Come on, say it. Hopefully you're right. Amplitude is 3. Tell me the amplitude on this one. Not negative. Sorry. It was 4. You always take the absolute value. All right, next ones. How about the period? We'll always start with 2 pi. It takes 2 pi radians for a trig function to repeat. But since there's a 4 in here, divide by 4. You get 2 pi fourths, or you get pi halves. So on your x-axis, every pi halves, this sine graph is going to repeat itself. Or here for the cosine, take 2 pi. Let's divide by 1/3. That's kind of strange. How do you divide by a fraction? Multiply by the reciprocal. So it's 2 pi times 3 over 1. So this period is going to be 6 pi. So this graph is going to occur very, very slowly. That one's almost worth taking a look at. So it's a cosine of 1/3 x. Turn everything else off now. Take that, and let's go cosine 1/3 x. Oops, I think I got something extra in there. Let's try that again. So let's go cosine 1 divided by 3 times x. And let's hit graph. And you can see that cosine graph. And let's just keep that here. You can see that cosine graph. But when I go from 0 to 2 pi, I don't get a whole lot of it. I get just about a third of it, don't I? Because the period there, that's not the period, but it's going 1/3 as fast. To see the whole graph, I'd have to come out to 6 pi to see that. So let's take that window again. And if I went from 0, oops, hit window. If I went from 0, if I went to 6 pi, so that's about 18 or 20, then I would get that whole cosine graph. And again, it's very important when you draw these graphs to label your axes. Otherwise, they all look the same. And so it's important that you would label that graph and say, look, I'm going from 0 to 6 pi now. Okay, a couple more. Let me just see what else I've got here. I think I have, you've got it in front of you. Yeah, 4 more of these to graph. And this is where we'll spend a lot of our time and get a lot of practice. Can you graph these functions? And it will take a little practice, especially with the period. And then in the next section, we add in even more. So you want to get a good foundation on this before we move on to the next section. Okay, so I've got the 4 here. 4 here in front. I know that affects the amplitude, so notice this graph goes from -4 to 4. That's nice. I see the 2 in here. So the period, it's normally 2 pi. It gets divided by 2. So this is going to repeat every pi radians. When I draw my graph, I'm just going to bring it out here to pi radians to see the whole graph. And I label that. Then I had all these key points. Remember we had 0. Remember we had pi halves. Remember we had pi, 3 pi halves, and 2 pi. Well, guys, every single one of these gets divided by 2. So I divided that by 2, and I had my pi. I'll just write that again. I had pi right there. Or here, I divide it by 2, and what used to be pi is now pi halves. Or take 0 divided by 2. Oh, never mind. That's still 0. Got that. Pi halves divided by 2. How do you divide by 2? You multiply by the reciprocal. So pi halves now becomes pi fourths. So label that pi fourths. And likewise, 3 pi halves now becomes 3 pi fourths. All right, do you still remember your key points for sine? If not, go back and look at them. Sine starts at 0. It used to be 1. Well, look, it's now multiplied by 4. Then it was 0. 0 times 4 is still 0. Down to -4. And back to 0. And how did we do that? You know, hopefully intuitively that's making sense. If not, in the second one, on the next page, I'll pull out that sine graph, or that chart with the key points. We can look at it again. Okay, next graph is very, very similar. We had our key points. We had 0, pi halves, pi, 3 pi halves. Oops. Acting a little funny on me here. See if it comes back. So 3 pi halves. These smart boards are great, except when they stop working. And it's blinking right now. So it's 3 pi halves. I think we're back in action here. Let's try it. 3 pi halves and 2 pi. Oh, look. There's a 3 in here. All of these get divided by 3. And again, how do you divide by 3? It's the same as multiplying by the reciprocal. So multiply by 1/3, I get a 0. I get a pi 6. I get a pi thirds. Look at that, the 3's cancel out. I get that's a comma. I get a pi halves. I get a 2 pi thirds. So these are great practice with your fractions. So here's pi 6, pi thirds, pi halves, 2 pi thirds. What about the amplitude? It's 2. Remember the cosine? It starts up at 2. So you've got a 2, to a 0, to a -2, to a 0, to a 2. And you get your nice cosine graph. You can tell from here the x-axis, it's been condensed. The whole thing happens in 2 pi thirds. And from the y-axis, you can tell it got stretched out. It goes up to 2. It goes down to -2. Okay, 2 more of these for you to practice on. We'll practice a bunch more in class. Let's just kind of go through these very, very quickly, and like I say, we'll practice a bunch more in class for you. All right, 4x, all your key points get divided by 4. 2 pi divided by 4 is pi halves. Pi by 4. Pi fourths. This will be a pi eighths. And a 3 pi eighths. And again, we can practice those if those aren't making sense. Negative in front of it. So I've got my same sign graph. It's just flipped over. So I don't go up 1, I go down 1. And I get a sine graph that looks like that from the the y-axis. I can tell it was flipped over. The x-axis, I can tell, wow, that's occurring 4 times faster than it used to occur. And our very last one, cosine of 1/2 x. Divide by 1/2. Wait, that's the same thing as multiplying by 2. So everything in the x-axis gets doubled. 2 pi is 4 pi. Pi is 2 pi. Pi halves is pi. 3 pi halves is 3 pi. And that negative sign, we don't start at 1, we start at -1. To 0, to 1, to 0, to -1. Connect the dots. And we get a cosine graph. Why is it flipped over? Because of the negative. It goes to 1, 1 to -1, because, look, the amplitude is still 1. And that 1/2 makes it occur half as frequently. So now instead of 2 pi, it takes 4 pi to fit in that whole graph. All right, that's a lot. We'll take a couple days on class on this. This is the most important part right here. If I give you a sine or a cosine, can you graph it with the amplitude and the period? And that will take a little practice. Very important that the x-axis is labeled. Very important that the y-axis is labeled.